Welcome back again. As promised in the previous video, we are going to illustrate an example on how to use secant method to solve nonlinear equation. So let's go into the class. So the problem is to solve to the nearest four significant figures the nonlinear equation x cubed equals to 2x plus 5. So the first step, solution. So step one. So remember, sometimes you may be given the first initial conditions, or sometimes you may be required to find those two initial conditions on your own. So the first thing that you need to remember is the formula itself. So remember, secant method approximates a root to a given nonlinear equation by this formula: xn minus 1 f of xn minus xn f of x n minus 1 divided by f of x n minus f of x n minus 1. So this is the formula. And then number two, initial approximations to the root. So the first thing, let's now rearrange our equation in the form f of x equals to 0. So this will be obtained by writing x power 3 minus 2x minus 5 equals to 0. So from this one, it tells us that the function f of x is x power 3 minus 2x and then minus 5. So if you are not being given the initial approximation to the roots x0 and x1, it will be upon you to find them. And you find them by knowing that you know that two values a and b have a root between them to a given equation if the sign at a is opposite, sign of the function at a has opposite sign to the function at b. So if we try putting in 0, then you'll have 0 cubed minus 2, 0 minus 5. So we get minus 5. So this is a negative value. If we try to put in 1, so we'll have 1 cubed minus 2 times 1 minus 5. So 1 minus 2 is minus 1 minus, this will give us minus 6. So this is still a negative value. So the root cannot be between 1 and 0. If we try to put in 2, so we'll have 2 cubed minus 2 minus 5. So that will be 8 minus 4 minus 5. That will give us negative 1. So this is still negative value. So also root cannot be between 1 and 2. If we try 3, then we'll have 3 cubed minus 2, 3 minus 5. Then you'll have 3 cubed minus 2 times 3 minus 5. That will give us 16. So this is positive. So we are sure that root lies between 2 and 3. Or if we have another value, say if we put here 4, then be 4 cubed minus 2 times 4 minus 5. So this would be 4 power 3 minus 2 into 4 and then minus 5, that will be 51. So this is positive. So the root lies between values 2 and 3. So then we can check, let x naught be say 2, and let x1 be 3. So that tells us that a value between 2 and 3 will be a root to that given equation. So remember, we have xn plus 1 equals to xn minus 1 f at xn minus f xn, and then f of xn minus 1 divided by f of xn minus f of xn minus 1. It's very easy to remember the formula because there's some symmetry here. So once you have this one as x naught and x1, then find the value of the function at x naught. So when you put in 2, our answer was minus 1. And when we put in 3, our answer was 16. So therefore, x2 means n plus 1 equals to 2. So the value of n equals to 1. So will be 1 minus 1, 0. 1 minus x1 f of x0 divided by f of x1 minus f of x0. And then we put in the values the way they are. So x0 is 2, f of x1 is 16, minus x1 is 3, f of x0 is minus 1, and then f of x1 is 16, and then minus 1. So when you work out this one, you'll get 35 over 17, which is 2.05 8.823.529. So this is what we have as our x2, 2.058823529. So immediately you get x2, then you find the value at x2, value of the function at x2. So this simply means, remember the function is given by x cubed minus 2x minus 5. So the value of f of x2 will be x2 cubed minus 2x2 minus 5. So when you put in these values into that function and using your calculator, you find that the value of the function will be given by minus 0.39079918. I know there might be some slight difference at the last 3 digits because of different levels of accuracies of the calculators, but that should not be a problem. So, so x3, when n equals to 2, so x3 will be given by xn minus 1. So x1 f of x2 minus x2 f of x1 divided by f of x2 minus f of x1. So we replace in the values, so we get x3 will be, so x1 from our calculation, we got the answer to be 3. F of x2 is minus 0.39079918 minus x2 from our calculation is 2.058823529. F of x1, we got the answer to be 16. So we'll have minus 0.39079918 minus 16 point, so just 16. So that's the values of f of x1. So when you put these values into your calculator, we should get this answer. X3 would be given by 2.81263659. And then once immediately you get X3, so comparing this one to four significant figures as stated in the problem and the previous approximation, they are different. So you have to go to the next iteration. So you need to find the value of f of x3, which will be given by x3 cubed minus 2 x3 minus 5. Putting in these values into this equation, into this expression, we get f of x3 will be given by minus 0.147 and then 204064. And then at n equals to 3, then x4 will be given by x2 f of x3 minus x2 f of x3 minus f of x2 divided by f of x3 minus f of x2. So replacing the values, so we'll have x4 equals to x2 is 2.058823529. F of x3 is minus 0.14720464064 minus x3 is 2.08. X3 is given by 2.8 1, 2, 6, 3, 5, 9 into f of x2 from our calculation is minus 0.390 799918 divided by minus 0.147204064 minus 0.390799918. When you put this value into the calculator, you should get 2.09 482.146. So this one to four significant figures is 2.095. The previous one is 2.813. So these still, they are not the same. This and this are different. So we'll be forced to find x5. So f of x4 will be given by x4 power 3 minus 2x4 minus 5. Putting this value into this expression, you get f of x4 will be given by 3.04379094 times 10 raised to the power minus 3. So n equals to 4, x5 will be x3 f of x4 minus x4 f of x3 divided by f of x4 minus f of x3. So we'll have x5, putting in the values, 2.081263659 into 3.0437904 790.94 times 10 raised power minus 3 minus 2.09482.146 into f of x3. From our calculation, we had minus 0.147204064 divided by 3.04379.094 times 10 raised power minus 3 minus 0.147204064. When you put this into your calculator and simplify, you get 2.0945468, and this one to 4 significant figures will be 2.095. Because iteration 5 and x5 and x4 have the same value when rounded up to the stated level of accuracy, so therefore we conclude therefore the approximate root to the equation x cubed equals to 2x plus 5 is 2.095, i.e. x is approximately equals to 2.095 to nearest 4 significant figures. So just to reiterate, to apply secant method, you need 2 initial approximations for you to be able to work out the problem. So I'll do as many examples on the same, and if there's any question, please don't hesitate to contact me. Thank you.